Give me 1 second. I'm just working. I seem to have trouble with getting the YouTube stream to show up correctly on my website. So give me just a second. All right. Me this. All right, cool. If you are now on the live page on the our For the Rest of Us website, it should be working for you now. You may also be joining me on Twitter or on Twitch. So happy to have you wherever you are. I'm just getting a couple things set up, and then I will go ahead and get started. So if you are new, I've been recording lessons all week. I'm releasing a new course next month, and it's called Going Deeper with R. My material is really pitched at folks who are getting started, who have never used R. I've developed a free course. It's called Getting Started with R, and then a kind of intro course called Fundamentals of R, and this really builds on that. Yeah, I've basically been live streaming it as I record the lesson, so you'll see that. It's going to be pretty rough. I tend to do things multiple times, go back, and re-record as necessary, so just expect that. If you are watching and are interested in telling me who you are, where you're watching from, I'd love to know. You can put that in the chat of whatever platform you're watching on, Twitter, Twitch, YouTube, and it'll show up for me. I'm using a service called Restream, by the way, which if you do any live streaming is super cool because it allows you to broadcast yourself to all 3 platforms at once. All right, let me... I just have to get a couple projects set up because I have the project that I use to make the course, which is actually what you're seeing here on the screen. And then I have a project, I'll slide it over here, that is intended to mimic the experience that students have going through it. So I just called it, the course project is just Going Deeper, and I just called this one Going Deeper DK. So I'm going to go ahead and just rerun this code. So I'm kind of back at the point where I was yesterday. All right. Just 1 second, and then I will get started. Okay, cool. All right, let me move this out of the way. I just actually need to open up my slides. So I'm working through the data wrangling and analysis section. Let me pull this over here. I made all my slides in the Sharingan package within R using R Markdown in the Sharingan package. Super great package if you do if you want to make any kind of slides. All right, let me. Just got to get to where I was last time. All right, we did changing variable types, did all this recoding, etc. All right, advanced summarizing. That's where I want to be. Excellent. Okay, let me just make sure I know what is coming. Advanced summarizing. So I'm showing folks how to do, well, I'm calling it percents. I know it's technically proportions. I'm showing folks how to do that with using group by and mutate as opposed to group by and summarize. And then we're talking about ungroup, and actually I just see I have top N there, which I had a conversation with a Twitter conversation that is with Hadley mentioned that that's actually being there's some reasons why top N is confusing that function, so it's actually being I forget their terminology, not retired, but de-emphasized. So I'm going to actually switch this real quick. Let me just find all the top N. Okay, so I want to actually switch this to there is a slice max function. Let me actually run this all down to here. And the slice max function, it's currently actually in the development version of dplyr, but it's going to be in the 1.0 version that will be released in May sometime. Because my course is going to be released in May, I'm assuming everybody will have access to it, so I wanted to use that. So let me just take a look back at slice max. I think I can just do, let me just see an example. Yeah, so I just need to put the variable first. So the confusing thing is top N actually has the number of variables, or not variables, excuse me, rows that you want to keep first, and then the variable name, which is not consistent with how other functions in the tidyverse work. So slice max flips it around essentially. Yeah, perfect. Okay. So let me actually find all the places where I have that top N and replace it with slice max. Is that really all? Oh, okay. Let me just rebuild my slides and then I'll go ahead and get started. All right. Ungroup. Okay. All right, let me refresh this and then I'll go ahead and get started. Sorry, let me actually I just want to do one thing where I'm looking at where the students were last time, so. Okay, perfect. All right, awesome. Okay. All right, next we're going to talk about advanced summarizing. You, so far in your work that I've had you do, have gotten, for example, the number of folks in various race ethnicity groups per district. Let's say you want to know the percentage or the proportion of folks in those groups in each district. Let's talk about how you would do that using R. We're going to use, actually I don't necessarily like group by, I'm going to actually, I don't want the code to appear right away because I don't want folks thinking about, I know as soon as I put code up there, immediately what folks are doing is reading the code and thinking about it. And I actually want to have a second where they are just, where I can just talk about group by and mutate. So I just added those 2 dashes there. You'll see in a second. They just enable me to have the title come up before the actual code comes up. So for example, if I refresh this, I'm going to actually do one thing because I think these slides are just super slow to load, and I think it might actually be because I embedded a video. Let me see if that actually makes it go faster. In any case, now I have just group by and mutate. Okay. All right, this is fine now, so I'm going to go ahead and get started. Okay. Let's talk about some advanced summarizing techniques. Right now, up to this point, you have calculated the number of students in each... Hold on, let's try that again. Let's talk about some advanced summarizing techniques. Up to this point, we have calculated, for example, for your data, the number of students in each race ethnicity group per district. What if you wanted to calculate, say, the percentage or the proportion of folks in each group? Let's talk about how you would do that. We're going to do this using group by and mutate. In the fundamentals of our course, if you took that, you know we talked about group by and summarize. And that enables us to go from a larger data frame down to a summary. Using group by and mutate is going to enable us to get, in this case, proportions for each group. And because we're using mutate instead of summarize, we're not actually going to change the shape of our data. Well, we're going to add a add a column onto it. Let's talk about how this works. And let's think about our German speakers data that we've been using as just a toy example. So if we add on, we've gotten to this point where we reshaped our data. We then have the year as a variable that's now a numeric, which we talked about in the last lesson. Now, if we do group by year and do mutate, so that adding a new variable, which is PCT for percent, and I know this is technically a proportion, but I'm just going to call it PCT. And we say PCT equals number divided by sum of number. So in other words, it's going to get the percentage by getting the number in each row divided by the sum of the number. So in other words, the total for each year, because we have grouped by year. Let's actually show the data so we can see how this works. What we've done now is we have, for example, Alabama for 2017 is 1.6% here. I'm actually wondering now, because I have it sorted by state still, I'm actually wondering if I should sort it by year. I mean, it's not like I'm going to actually go through and show the whole thing. I think I should. Let me change this. Oops. So I'm just going to arrange then by year and by state. So let me add that in. All right, I'm going to go ahead and redo that. All right, let me refresh this. It doesn't seem like taking that video out did anything in terms of the speed of it. I'm not quite sure what's going on there, but I'm not going to worry about it. All right. All right, I'm going to start from this slide again. The way that we're going to calculate percents or proportions is by using group by and mutate together. In the fundamentals of our course, I taught you how to use group by along with summarize, and that enables us to get a summary for our entire data frame. But what we actually want to do here is we simply want to add a new variable that shows the proportion or percent of for each state in each year. So let me actually use, and I mentioned states and years because I'm going to use the German speaker data that we've been using as kind of a toy example. So remember with this data, we had reshaped it and then I used the parse number to get the year just to make that variable look nicer. Now, if we group by year and then do mutate, creating a new variable called PCT, and I have that equal to number divided by the sum of number, what that's going to do is it's going to take for each row the number there, and then it's going to divide it by the sum of number, but it's going to group by year. So in other words, it will group all 2017 German speakers, all the sum there, and then it will, sorry, I'm just thinking. Some number. Oh no, I don't have to deal with any NARM because all my numbers are 0. All right, let me start here again. So we're going to use group by and mutate to create. Actually, you know what? I'm not even going to record that section because I feel like I can edit that back in where I talk about the difference between group by mutate and group by summarize. So I'm just going to start it where I actually show the code. Let's take a look at our German speakers data that we've been working with up to this point. And I have a couple lines added on here that are going to use group by and mutate. So we've done some work up to the yellow. This is what we've done to this point. What we're doing now is because we want to see the percentage for each state as a percentage of the total population of German speakers for each year, we do group by year, and then we do mutate, and I'm creating a new variable called PCT, which is equal to the number. So in other words, the number for each state divided by the sum of number. Then what I'm going to do, and actually just to take one step back, the sum of the number here, this section, it will not add up the number for all 3 years. Instead, it will do it grouped by year. So it will do a sum for 2017, a sum for 2018, and a sum for 2019. And that's what we want because our data is at has one observation for each state for each year. And then I'm just going to arrange it by year and by state just to make it easy to look at. So when I do that, let's take a look at this. Now we have Alabama 2017 number 426, and that is 1.6% of the total of all German speakers in 2017 in our data set. And you can see we have the same thing for all of our other states. Okay, so that's how we've created a proportion or percent for each row here. Let's talk now about ungroup. Okay, I actually want to do the same thing here where before I show the code, I want to actually just talk about ungroup first. Okay. All right. Next, we're going to talk about something really important, and that is ungrouping your data. The group by function is incredibly helpful when we want to, in this case, for example, look at the percentage for each year. But it's important after we do this work that we ungroup our data so that we're now working at the level of the entire data frame. So let's give an example. I am doing here the same thing up to this point, but then I'm adding a new function here to see, well, I'm curious which state has the highest percent of German speakers. So I'm using the slice_max function, which chooses the top observation for a given variable. So the first variable here, or the first argument, is the variable that I'm using. And then the second argument here is the number of observations I want to look at. So when I run this, I get 3 observations returned to me. And that's not what I'm expecting, right? Because I did slice max PCT, 1. The reason that's happening is because my data is still grouped. So in other words, it's giving me the top percent in 2017, which is Ohio, top in 2018, Delaware, and top in 2019, West Virginia. Let's take a look at how we would do this by first ungrouping. So first thing we would do is before we actually use that slice max function, we just add a line here for ungroup. No arguments needed. Now when I run it, I just get the top observation in PCT for the entire data frame. In other words, not for each year. So let me actually take a look at this with the data that I'm working with. I'll calculate the percent of students at each school who are proficient in math. All right, let me flip over here. Okay. All right, let me take a look at my third grade math proficiency data as a reminder. I've got school ID, proficiency level, and then number proficient. So I want to take a look at the students in each school at each proficiency level, the percentage. So I'm going to group by school ID. Yeah, that's what it's called. And then I'm going to do mutate, and I'll call this PCT equals, so I want number proficient divided by sum of number proficient. Let me go ahead and do that. Let me take a look back at my data here, and you can see now I have the number proficient, and then I don't remember getting those NaNs when I was testing this out. Let me take a look back at this and just see if I did something different when I was testing it out. Oh wait, sorry, that's the wrong place. Oh, I know. Oh, I forgot to do something. How did I forget that in the last lesson? Hold on one second. Oh man, I'm gonna have to add this back in. I'll explain my thought process in just a second. Yeah. Okay. So the issue is, I actually want to demonstrate a more, in the last lesson, which I recorded yesterday, I was demonstrating case when, and I forgot to run this line or those few lines in my code to demonstrate how case when works. Hold on, I'm just thinking through this. Yeah, because I don't really want to I don't really want to talk about different types of NAs. I think it's just beside the point for what I'm going over now. I want to keep it really focused. So I think I need to go back and add something in the case when my turn. So I'll then use case when. To calculate the or no, to convert the, what was the variable called here? Proficiency, yeah. Proficiency level into a dichotomous, i.e. Proficient, not proficient. I'm actually thinking about whether I should now, oh man, I feel like I'm like totally redoing this now. Maybe this advanced summarizing should be part of the kind of group by summarize that I have here. Should be part of the next lesson. Yeah, because this lesson is really focused on advanced variable creation. Yeah, I want to put this back here. So and then I think what I'm going to have to do here whoops. All right, let me redo this. I'm just thinking if I need to go back and through the magic of editing, I can do this, I think, but let me just change one thing. One thing I've made sure to do today is wear the same shirt so that when I edit, you don't notice if it's recorded on a different day. Hopefully you don't notice my stubble growing slightly longer each day. All right. Okay, I am going to do this. I'm going to stop this recording. I'm going to call this Advanced Summarizing Part 1. I'm going to start a new video that's going to be for the where I'm just going to record the case when solution. The additional portion of it. So let me actually just record the oops. I'm just going to record myself doing the my turn slide, and then I will go back and redo that so the my turn coding, and then I will go back to where I was. Okay. back here. All right. So for my turn, I'm going to convert all instances of the proficiency level variable to more meaningful observations. Right now they're listed as number level 1, number level 2, which is an artifact of how the data was structured before. I want to get them just to say 1, 2, 3, 4. And I'll do that using all of these options that I've run through: recode, if else, str remove, parse number, case when. Then I'm going to use case when because I actually want to convert the proficiency level into a dichotomous, i.e. I want to make it proficient or not proficient. And I'll demonstrate how I can do this using case when. Okay. Bring back up the going deeper decay. Just going to run this again. All right. So now I'm recording me doing the second part of the solution. No, they're not the solution, it's the my turn, which will be edited on after the fact. So what I'm going to do now, and if I take a look at my data, you can see I have school ID, proficiency level, number proficient, and I just ended up using the parse number because it's the most efficient way to do this. You could leave your code with any of the other options: recode, if else, case when, etc. What I want to do though now is I know that the proficiency level is actually, if you get a 3 or a 4, you're considered proficient. If you have a 1 or a 2, you are not considered proficient. So let me actually code that proficiency level variable into that dichotomous proficient, not proficient. So the way I'm going to do this is I'm going to use mutate, and I'm going to overwrite the proficiency level variable. And I'm going to say case when. So again, as a reminder, if it's 1 or 2, it's not proficient. If it's 3 or 4, it is proficient. So I will say, so if proficiency level is greater than or equal to 3, then proficient. And there are a couple ways I could do this. The simplest way would actually just be to say true is not proficient. So in other words, everything else is not proficient. So let me run that. And you can see now that was 1, that was 2, those are not proficient, 3, 4 proficient. Okay? And just to show you, if I did proficiency level is less than 3, not proficient, so if I run that, you can see I end up with the same exact thing. Because I like elegant short code, I'm going to use true there. But it does the same thing. Okay. Okay, I'm going to stop recording that. Let me just relabel this case when my turn part 2. And okay, now I'm going to go back to where I was. And I'm going to do this my turn section again. Oops. Give me just a second. just putting little pauses in there, which I like to do. While I'm waiting, if you are up for telling me if you're watching, who you are and where you're from, I'd love to know. It's always interesting to me to know who's following along. And you can put that in any, whatever service you're watching on, just put in the chat. All right. Okay. Let me make this full screen. So for the my turn, I'm going to calculate the percent of students at each school who are proficient in math. And to do this, I'll actually need to use a couple things. I'll need to use group by and summarize, and then group by and mutate. And I can't forget to ungroup at the end. All right, let me flip over here. Oh, wait. That's the wrong project. Let me bring up the right project. Okay. All right. One second. All right, I want to get the percentage of students who are proficient in math at each school. Looking at my data, the way I left it from last time was I had school, and then I had proficiency levels here. And you can see I actually have 2 rows for each school, because if you remember, this was proficiency level 1 and proficiency level 2. So I'm going to actually begin. I need to combine these here. So the way I'm going to do that is I'm going to use group by, and I actually want to group at each school. Basically, I want to add, for example, 37 plus 25 for this school. So I want to group by the school ID and the proficiency level. So I'm going to group by school ID and proficiency level. And now I'm going to use summarize. Because I'm not actually trying to add a variable onto here, I want to actually change the shape, especially insofar as I am combining I'm summing these 2 numbers. So now I'm going to call or number proficient equals sum of number proficient. So when I do this now, it'll be grouped at the school ID, grouped at the proficiency level, and it will add 37 plus 25. It'll also add 24 plus 12 for school 2. So just to check it, after I run this, school ID 2 proficient should be 36. So let me go ahead and run that. And you can see it is. Now the one thing that I want to do, I want to make sure now that I ungroup. Because as you saw before, that can lead to issues with data being grouped and kind of not realizing it. All right, now I know the percentage of students, or excuse me, the number of students who are proficient at each school. Let's see if we can convert this into a percent. Technically a proportion. So I'm going to group by school ID. I don't need to group by proficiency level because I just want to group. I want to see at each school how many students are proficient, how many are not proficient. So now I'm going to do mutate. PCT equals number proficient divided by sum of number proficient. Let me run that. Take a look. Why do I have NaNs again? Oh, because there are zeros here. But why did I not get that? Hold on one second. Oh, because I added a drop NA for number proficient. Yeah, okay, maybe I just have to talk about the NaNs. Yeah, that's fine. Let me make sure. NaN stands for Na numeric. It stands for not a number. Okay. Okay. All right, so I'm going to go back to the point where I'm actually running the code. All right, let me take a look at what that leaves us. So I've got, for example, school ID 2, 62, not proficient is 63%. For 36, the number who are proficient, that's 36.7%. Checks out. Now you'll notice that I'm getting some NaNs here. That stands for not a number. It's a special type of Na. And the reason is, as you can see, there's zeros here. We can't calculate the percentage of students who are proficient because we don't have any students for whom we have observations in the not proficient or proficient group. So I'm just going to do one thing. I'm just going to use the drop NA function just to drop any NAs in the PCT variable. Yeah. So now you can see any NAs there. We just got rid of those. I know there are reasons why you might want to do things with them. For simplicity, we're only going to deal with schools where we actually have that data. And last thing I'm going to do is, again, I'm going to ungroup just to make sure I don't run into any issues in the future. All right. Okay, let me flip over here. For your turn, I want you to create a new variable called PCT that shows each race ethnicity group as a percentage of all students in each district. You're going to need to use just group by and mutate. And don't forget to ungroup at the end. Okay. Just as a reminder of where we left off, we have enrollment by race ethnicity. And you can see we have district ID, race ethnicity, number of students, and we made race ethnicity look nicer using case when in this case. So now I want to calculate the percent of students in each district in each race ethnicity group. So I'm going to do mutate PCT equals, what's the number of students divided by the sum of the number of students. And actually I can see if I run this, I'll actually have an issue. I have an issue here because I forgot to group by. I need to group by each school. So it's actually calculating the percent for for each district. It's actually calculating the percent for all districts, which is not what I want. So let me group by district ID. And then I'm also going to add my ungroup at the end. Okay, let me open this. Yeah, that looks much better. So you can see, for example, for district ID 2063, 2 students who identify as American Indian Alaska Native, and that's 25% of the total, which makes sense because it's a very small district. There are only 6 other students, all of whom are white, and that's 75% of the total. All right, let me stop recording. Just saving the video. All right, start recording again. Let me take a look. At what I'm doing for this next one. All right. Cool. All right, next thing we're talking about is binding data frames. There are 2 ways to bind data together. We're going to talk about bind rows, which takes one data frame and metaphorically binds all the rows together. So I think of it as like top, you have an original data frame and then you put rows, additional rows on the bottom. And then there's bind calls, which does the opposite, which binds columns onto the end of the data frame. Let me give an example here. Let's say I have 2 data frames. One is German speakers 2018. One is German speakers 2019. You can see data pretty simple and totally fake. Let's say I want to put these together into a single data frame that's just German speakers. The way to do this is using the bind rows function. And the way I do this is I create, in this case, a German speakers 2018-2019 data frame. I assign that to the results of bind rows. And with bind rows, you just list the data frames that you're binding together. So when I do that, you can see now I bind the rows and I've got state, number, and I could go all the way down. Now, one issue you're probably realizing here is I don't actually know what year the data that I'm looking at comes from, right? Like I'm looking at Florida 958. Well, is that 2018? Is that 2019? So we can solve this by simply adding a line before we bind the rows. So I change the German speakers 2018. I add a mutate. And I say year equals 2018. Same thing for 2019. And now when I bind them, you can see now I have state, number, year, and if I scroll all the way through, now I have 2019 data here as well. You know, give me one second. Yeah, I'm actually wondering. So there is an ID argument in bind rows. me just see something. .id. To be honest, I don't actually use it. I usually just add it manually, and there's some reasons, I think teaching-wise, it might be more effective to show it with the mutate because it separates things out into individual steps. Looking for an example of how this works, because clearly I don't actually do this. Oh, so you could just call it ID. Okay, so that gives you ID. It does 1 for the first data frame, 2 for the second one. Yeah. I actually like my way of doing it better for someone starting out, I think is a bit more intuitive. I'm just wondering if I should like show the other way of doing it. So I think I'm going to go back here and just record from here on out, and I'll mention that so if folks want to take a look at it, they can. So the way we're going to deal with this issue is we're going to add a mutate line for each data frame. So you can see here, for example, I'm going to take German speakers 2018, overwrite it by adding a new variable, which is going to be year, and I'm going to assign the results to be 2018. Same thing for the German speakers 2019. Now when I run this, you can see I have a year variable, and you can see I'm actually at the point here where it breaks from 2018 to 2019. But before that, it's all 2018 data. After here, it's all 2019 data. I should mention that there is an argument within bind rows that's .id. If you want to systematically, you could add an argument here, that .id, to give an ID variable. You could do it programmatically, in other words, not having to add this mutate line. For now, I think this is a simpler approach and one that's going to make more sense for us starting out. There's also a bind calls. Hold on, let me start that again. There's also a bind calls function, and that will put additional columns on the end. So let's actually take a look at what happens if I do everything the same, except that I've changed right here, bind calls. So when I do that, you can see now I have state 1, number 2, year 3, and it simply added on state 4 as the variable name. Whoops, I should scroll over like this, number and year. So it's given us additional variables. Now, if you recall back to the tidy data section, having a data frame in this format with, in this case, for example, 2 state variables, so there's a state 1 and then state ... 4, that's not actually tidy data. So in this case, actually using bind calls is definitely not what we want to do. There are cases when it does make sense, but in our case right here, it's not going to lead to tidy data, so we're not actually going to use it. What you're going to see in the next lesson when we talk about data merging is that when you want to add additional rows on, often what you're going to do is use one of the join functions as opposed to bind calls. All right, I am now going to import 2017-2018 math proficiency data, and then I'm going to use bind rows to make a 3rd grade math proficiency data frame, which will have both 2017-2018 as well as 2018-2019. I always go too fast. Sorry, I hear my children. So for my turn, I'm going to import 2017-2018 math proficiency data, and I'm then going to use bind rows to make a third grade math proficiency data frame which has both the 2017-2018 data as well as the 2018-2019 data. Okay. Just gonna wait a second. My children are headed outside, so let me just let them do that, and then I'll start up again. Hi, Felipe from Colombia. Thanks for joining. I hope it's helpful. I know this is me kind of, going through multiple times. You know, I guess I want to show people kind of what it looks like to actually make a course, but yeah, it's messy. All right, give me just 1 second. I think my kids are just about to head out. All right, I think they're just about to head out. It's a rainy day here, so they're getting their raincoats and everything on. Okay, they just headed out. So let me go ahead and do the my turn. Okay. So just as a reminder, this is what our third grade math proficiency 1819 data looks like. I want to create a third grade math proficiency data frame that's going to have data from 2017, 2018, as well as 2018, 2019. Now here's the super cool thing. All of this code that I've created up to this point, I can actually reuse this. Because if I look, for example, at my math scores 18-19 data and my math scores 17-18 data, which is the data as I read it in, kind of the raw data, it all has the same structure. So let me just copy this whole thing, and I'm just going to change a couple things, right? So I'll make this this third grade math proficiency 17-18, and instead of starting with the math scores 18-19, I'm going to start with 17-18. So now I can just rerun this. So let me run that line, or those lines I should say, and open up third grade math proficiency 17-18. You can see in no time at all, I have summarized this as well. So now to make a data frame that combines everything, I'm going to simply use bind rows. So I'm going to call it third grade math proficiency, and I'm going to do bind rows, and I'll do third grade math proficiency 17-18, as well as third grade math proficiency 18-19. Now if I run that and I take a look at it, looks good, except I forgot to add the year, right? Like I don't know what year this is from. So let me go back up here and just add mutate year equals 20, let me put this in quotes, this is 2018, 2019. I'll just copy that line, put it down here, 2017, 2018. So I just need to rerun this code chunk, Control Enter, or Command Enter I should say, I'm on a Mac, and then rerun third grade math proficiency. Let me open that back up, and you can see now I have year as well. So once you've written the code for 1 year, you can simply reuse it for the next year, bind rows, and wow, all of a sudden you have third grade math proficiency for 2 years. And in fact, you could even use this for multiple years. All right, close all these. Okay, so for your turn, you are going to import 2017-2018 enrollment data into a data frame called enrollment by race ethnicity 17-18. Clean it using the code that you already created for the 2018-2019 data. And then I want you to use bind rows to make an enrollment by race ethnicity data frame. All right, just as a reminder, this is our data from before, enrollment by race ethnicity 18-19. So let me just copy this. I'm going to change this to 17-18. And I'm going to start with 17-18. Cool. Oh, and I realized I forgot to add my mutate year equals. This is 2018-2019. Let me copy that, put it down here. 2017-2018. All right, so now let me go ahead and run that. Let me open up my enrollment by race ethnicity 17-18. Oh boy, that did not work. Oh, I'm too smart for myself. I actually realized that there, and that was intentional. All right, let me start at the point where I'm opening that up again. I'm going to pretend I'm surprised so then I can talk about what's different. Okay. All right, let me open up the enrollment by race, ethnicity 1718 now. And, that column does not look right. Let me take a look back at this and try and figure out what's going on. So if I look at the enrollment 1718, and I kind of scroll through here, oh, you know what? I'm actually seeing something here in this line. See if you can take a look and figure out what might be going on here. There is an issue here because all of the, you know, I'm just thinking I probably want to, this is going to be really hard for people. I think I'm going to add a hint here because otherwise people aren't going to figure it out. You're going to need to change some of your code. I'm going to be more explicit. So to make the race ethnicity, actually let me call it race variable, get recoded correctly. All right, let me rerun that. If anybody does have questions as I'm going through this, please feel free to put them in the chat. All right. Okay. Wait, that didn't show up with the... Where's my hint? Why is that not showing up? Try one more time. Maybe I need to reknit this. Okay, super weird. Let me just reknit this. Okay, why is that not? I have no idea why that's not showing up. Just trying to clear the cache, see if somehow that's an issue. Let me remove that to have it show up right away, see if that works. I genuinely do not know what's going on here. All right, let me refresh this. Okay, now it's showing up, but why? I always do it like that. I don't know why that's not working. Let me try it again. I'm just going to reknit it one more time. If it doesn't work, I'll just leave it up. Okay, I don't know why that's not working. I'll just let my perfectionism go and have it show up right away. Okay, I just need to actually go back to where I was. All right, for your turn, I want you to import 2017-2018 enrollment data into a data frame called Enrollment by Race Ethnicity 1718, and then clean it using the code that you created for importing the 2018-2019 data. Then I want you to use bind rows to create a combined Enrollment by Race Ethnicity data frame. And just as a hint, because you're going to actually run into issues with specifically the race ethnicity variable. Something is not going to be recoded correctly. And so I want you to take a look at your code and adjust it as necessary to make it work for the 2017-2018 data. Oops. Okay. Just going to restart my session, run that again. All right, here's my enrollment by race ethnicity 2018-2019 data. And let's go ahead and do the same thing, but for 2017-2018. All right, so I've copied this code from up above, and first thing I'm going to do is I'm going to change it so it's 1718, 1718, and I'm going to run that. Let me open this up. Ooh, and I am seeing an issue because that race ethnicity variable is showing all NAs. Let me take a look at my original data, my enrollment 1718 and enrollment 1819. Let me kind of compare them. All right, so for enrollment 1718, district ID, and then a bunch of variables about male, female, and then various groups. Oh, you know what I'm seeing? The variable names for the enrollment 1819 start with X 2018, 2019, whereas for enrollment 1718, they're starting with X 2017, 2018. Let me look back here. Oh, you know what? Look at my code, look at this line. I have set it up so for race ethnicity, it actually just removes the line, or removes the text X 2018, 2019. But that's not going to work for the 2017, 2018 data. What I'm going to need to remove is the 2017, X 2017, 18. So let me just change this slightly, and then let me see if it works. Run that, pop this up again. Okay, cool. It looks like it mostly worked, but not entirely. Let me do this. Let me run the code up to this point. Oh, you know what I'm also seeing? I've got male and female here in 2017, 2018. Whereas in 2018, 2019, I don't have that male, female data. Okay, you know what? I actually... I actually don't even want, that was just a mistake. I actually don't want the data to have that male-female data. I think I just accidentally left it in. Let me delete that. I'm going to close that. And then let me also actually go in to my course project and edit this file as well. Delete those 4 rows. Okay. All right, I need to go back now to this point. Restart my session, close all of my windows. I hope at the very least, just for people watching, I hope it's helpful to see kind of like the thought process. In a lot of ways, you know, it's the same as what you do when you're working in R, because like I'm figuring out what the issues with my code are. It's a bit meta insofar as I'm doing it and having to think about how it's going to come across for students, but hopefully it's helpful in some way. All right, run this again. Okay, I'm going to go back to the beginning. So let me take a look at my enrollment by race ethnicity 1819 data. All right. Now, I should be able to basically copy that and run the same code for 1718. So I'm just going to need to change what it's coming from. And just as a reminder, we, in the very beginning, imported 1819 from Excel, and the same thing for 1718. So I should be able to run this And now let me open up enrollment by race ethnicity 1718. Huh. First thing I notice is that within the race ethnicity variable, I'm getting all NAs. So I'm going to have to look at that. Let me do this. Let me open up my enrollment 1718 data frame as well as my enrollment 1819 data frame. So enrollment 1819, I'm looking at the variables. Oh, one thing I'm noticing, the variables in the 1819 data frame start with X 2018-19, whereas in the 1718 they start with X 2017-18. And if I look back at my code, look at this line. I've set it up so that the race ethnicity variable up to this point, like let me actually just run the code up to this point and open up my enrollment by race ethnicity 1718. I want to remove that portion of it. However, I have set 2018-2019, whereas I'm going to change it here to 2017-18. Now let me rerun this, open this back up. There we go. Now I have it so my race ethnicity variable works. Okay. Wait, I'm looking at my code. Okay, so this is the last lesson I'm going to cover today, functions. I actually forgot to get a background image for, I like to have a background image for each section. And I forgot to get one. So I've been getting my images from Unsplash. His cool royalty-free images. Let me find one. I don't like using that kind of thing because it's from other languages. It confuses people. I like sort of like abstract things that sort of mean function. It's interesting. They're doing like function as in like an event. It's a good image for function. Try code. If it's like blurred enough, I actually kind of like that. That might work. Oh, that's a cool picture. I think I'm going to go back and use that heart one. Okay, really quick, I'm just going to download this. Just 1 second, I just need to resize it. Code heart. Let me shrink the size of it slightly. Okay, close that. Just gonna copy this here. Oops. Code heart. Just reknit that. let me refresh this, make sure it's got that image. All right, cool. The next thing that we're going to talk about is making functions. Why would you actually want to consider making a function? There are a number of reasons, including you can give functions names. Hold on one second. This is a little too abstract to start out with. I'm actually wondering if I should start with when to use a function. Yeah, because then I can refer back to what folks have done. So I'm going to have folks basically make a function that brings in data, because as you can see, we basically copied the same thing here, and we can actually make that into a function. Oh, I put that Vimeo video back in. Actually, I think the Y, whoops. No, come back. Yeah, no, maybe it's actually okay. So we talk about when to use them, why use them. I think what a function, no, go away. What a function is should probably come first, then why, because people aren't going to understand the what if they don't understand, or they're not going to understand the why if they don't understand what a function is in the first place. So in this case, in this video, I'm actually doing it, or in this lesson, it's actually slightly different because I've made a video, this blog post here, where I actually walk through how to make functions in R. So instead of just having me, recreate something with the German speakers toy data set, I'm actually just going to show people, have people watch this video in the course, because I think it's going to be better than me just making something. Yeah, so basically I'm going to talk about when to use a function, then they'll learn about it using that what a function is, then we'll talk about why use functions, and then I'll give an example with my data. Okay. Actually, let me just make sure I refresh so I have the most up-to-date version. Let's talk about functions now. Functions become important when you see yourself copying code over and over and over. And you should consider writing a function whenever you've copied and pasted a block of code more than twice. In other words, you now have 3 copies of the same code. Now, in the last lesson, we copied code to import 2 years of data. So we're not actually at that kind of threshold, but it's an example of where we can refactor, in other words, redo our code to now use functions. Let's talk about what a function is. And instead of me making an example with the German speakers data set, say, I actually wrote a blog post that includes a video about how to make functions. So I'm actually just going to have you watch this video now. So for those watching live, I'm now going to splice in that video. Now that you have a sense of what functions are, let's talk about why you might want to use them. Using functions, you can give each function an evocative name that makes your code easier to understand. So if your function is called import race ethnicity data or clean race ethnicity data, it's pretty clear what it does, right? So that helps when you're looking back at your code later on. You can also improve your work because anytime you need to make changes, if you've written your code into functions, you only have to change the code in one place. So for example, if you realize that you miscalculated something, if you've copied code 5 times, you have to find each place, rewrite your code. Whereas if you've written it as a function, you simply have to find the one place where you make that calculation, change it. Anywhere else in your code that calls that function will use the updated version. You also eliminate the chance of making mistakes when you copy and paste. And these 3 reasons come from R for Data Science chapter 19, which is all about functions that I definitely suggest taking a look at. So for my turn, I'm going to do this. I'm going to create a function to import each year of math proficiency data. Then I'm going to use bind rows to bind them together. All right. Let me close those. All right. Why is this going so slow? Okay, there we go. All right, I'm going to make a function, and I'm going to do that to import my data. So looking at this, let me make a function that imports, or that actually, hold on, let me start that again. All right, I'm going to make a function that is going to clean my data. So to do that, I'm going to call this clean math proficiency data. That's going to be the name of my function. And I'll do assign that to, and then I'll write the word function with the open parentheses, close parentheses. I'm going to add arguments in a second, but just to show you how I might begin by doing it. So I could just copy in that code. And if I run this now, all of the code that's in here will be run anytime I type clean math proficiency data. So if I run that, it actually returns the data frame here. I haven't assigned it to anything, but if I, for example, assign it to third grade math proficiency 1819, now if I open third grade math proficiency 1819, you can see I have exactly what I need. Okay? So I'm going to actually get rid of all of my code down here because I no longer need that, right? I have my function here. Now thinking about this, there are a couple things that are going to change from one year to the next. Like this works fine if all I want to do is import 1819 data, but I want my function written in a way that'll import any year's data. So the first thing I'm going to need to change is the math scores 1819, right? Like I don't want to have the function just use that data frame. I want it to use whatever data frame I tell it. So I'm going to give an argument here that's raw data. So now if I run this, anywhere here, whatever data frame I give it as an argument will show up here where it says raw data. So for example, if I run that, now if I try and run this, for example, I'm actually going to get an error. It's going to say raw data is missing. But if I type in math scores here, and I could even type in raw data equals, now that works, right? Because it's taken where it says raw data here and it's put in math scores 1819. Let me actually try this. Like what if I now put in 1718 and I just change this to 1718. So if I run that, open that up, it looks good. The only thing though is year here is off, right? I don't want that to be 1819 now. I want that to be 1718. So I'm going to add, I want to change this. I don't want that to be that. I'm going to call that data year. So now my function has two arguments. If I run it now, it's going to give me an error because it's going to say I don't have data year. So now I'm going to add here year equals 2018, 2019, or sorry, that's should be data year equals 2018, 2019. So now if I run this, when I have this mutate function here, data year is going to be replaced by 2018, 2019. And let's actually run this and see. Yep, 2018, 2019. And let me copy this here. And this will be 2017, 2018. So let me run that. And perfect. That has now, the year is now 2017, 2018. So now I could do third grade math proficiency and have that be bind rows, third grade math proficiency 17, 18, and third grade math proficiency 18, 19. Run that. And you can see now I have my giant data frame, super long data frame with my data from both years. And what our function has done is it's simplified our code a lot, right? We basically had the same thing twice. Now we have it just in one place with a couple arguments that change each time I run it. So the raw data argument and the data year are the two things that change when we import 1819 data and 1718 data. All right, last thing I'm going to do. Open this back up. All right, for your turn, I'm going to have you create a function. It's just to import each year of data. Did I say that in the my turn? Yeah, let me change that because it's not really well, it should be import and clean. It should be clean, actually. Hold on, let me... So I'm just going to record myself doing the my turn, then I'll do the your turn slide, both of those slides, and then I'll record the your turn solution. And then I'm going to call it a day. Whoa. Okay. So for my turn, I'm going to create a function to clean each year of math proficiency data. All right. Hopefully this will be the last issue. Thanks to everybody, by the way, for sticking around. I appreciate you helping to provide public accountability for me to get these lessons recorded. Thank you. All right, should be good. Okay. For my turn, I'm going to create a function to clean each year of math proficiency data, and then I'll use bind rows to bind the two data frames that I get together. For your turn, I want you to create a function to clean each year of enrollment data, then use bind rows to bind the 2 years of data together. And then in addition to the argument for year that you'll use when creating your function, you'll also need to use it. All right. Just redoing that slide. Thanks, Francis. Just so you know, appreciate you following along. Okay, let me see if this works the way I want it to. Yeah. For your turn, I want you to create a function to clean each year of enrollment data and then use bind rows to bind them together, so to bind the 2 rows or the 2 years of data together. In doing this, you're going to need to use a couple arguments. One is going to be for the year of the data in that mutate line. And then you're also going to need to use an argument that will be the text that gets removed in the str remove line. Okay, hopefully I got that correct. Rerun this. All right, let me convert this into a function. So I'm going to call my function clean enrollment data. Make that a function. The way I usually start out is kind of how I did in the my turn section. Let me just copy that here. And I'm going to just delete everything else here. So clean enrollment data. And if I run that, it will give me, this is the code that worked for 1819. Okay, so I want to change a couple things though, right? Like I need to change the raw data, just as I did in mine. I also am going to need to change, it looks like I forgot to add the year here. So I'm going to, year equals data year. I'm going to add that as an argument here. And then the other thing I'm going to need to change is this text, right? Because that changes depending on what year it is. So I'm going to call that race, ethnicity, remove text. Okay, so now I'm going to copy this here, like that. Okay, let me run that again. So now raw data is going to be enrollment. Let me do it for 1819, enrollment 1819. That year, the data year, and let me actually add, let me do this. Raw data equals, I'm just going to add all the argument names so it's really clear what I'm doing. Data year equals 2018-19, so that 2018-19 will get replaced right here. The raw data is enrollment 18-19, that will go right here. And then last thing, what's the text that I want to be removed? So, whoops. Race, ethnicity, remove text equals, and it was x 2018, whoops, 19 underscore, I think. Let me run this and see if that looks good. Yeah, perfect. All right, now let me assign this to enrollment by race, ethnicity 1718. And I'm just hitting select all and then Control or Command I to indent my code, make it look nice. Now I can copy the same thing and just adjust it slightly. So the enrollment data is now coming, it's enrollment 1718. The year is 2017-2018, and the text I want to remove is X 2017-18. Let me run that. Let me pop this open, and yes, this looks right. Got my race, ethnicity correct, got my year correct. Excellent. So now I could just do enrollment by race, ethnicity, and assign that to bind rows, enrollment by race, ethnicity 1718, and enrollment by race, ethnicity 1819. Take a look at that. And yeah, that looks good. And I can even see over here, that's 2,940 variables, which is double the amount for each year, which is how I know it's correct. Okay. All right, folks, thanks to everyone who joined. I appreciate you joining. If you have any questions, feel free to follow up with me. If you're interested in the course, it's on the Art for the Rest of Us website. Yeah, thanks. I will I will definitely be back next week I will post some times. It'll almost certainly be the same kind of 10 o'clock time, probably Monday, Tuesday, Wednesday. Just need to check a couple things. All right, folks, thanks a lot. Appreciate